Hello, this is a short video on first break picking, and we'll show you how to load the data, pick the breaks, and we'll have a look at the pick file at the end. Shouldn't take that long. So whether or not you're familiar with Steno, to load a seismic file you can click on the load seismic file button, or you can go up to display and do the same thing, open seismic file. I'll pick a file here that's got, basically the trace headers are updated. So if we need to look at shot gathers, we can look at shot gathers. Scale this both vertically and horizontally. Amplitudes, increase the window length of the AGC. And to start picking, we'll go over to the list of pick types: event picking, first break picking. We provide a file name. I'll call it first break picks. What we're given on the left side of the application here is a widget that contains all the controls we need to pick the breaks and save the breaks. You can see that the name we provided is up at the top here. It suggests that the output file that contains all the picks will be in a text format as opposed to binary format. There's some options here to autosave at a given record increment, and that means that if you finish picking a record and you go into the next record, it automatically saves the file when you go to the next record. So if your save interval is one record, every record through the file you're going to resave the entire data set of first break picks. If you have a small 2D line, I wouldn't worry about it. If you're picking a larger data set, you'll notice as you go through that you start to waste a little time saving and saving and saving. So you might increase that interval. Alternatively, you can just hit save, the manual save, and anytime you do that, you save the picks. So let's take a very simple example of picking a first arrival. By default here, you can see we're on a single trace pick. I'll set the pick phase to trough. Boom, you have a pick. You can increase or decrease the size of the pick there. We can choose another method, what I call linear guided. That means you're going to place one pick, another pick, and it will draw a line between those two and look up and down from that line 24 milliseconds and try to find, in this case, the maximum trough on each trace. So if you had lots of time, you could make your picks that way. Actually, what I meant to do, it doesn't affect that. Let's go to the shot domain and again make a pick, 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 pick. The alternative to that, the only other alternative at the present time, I would say, that to single and linear guided picking is what I call semi-automatic. So semi-automatic will pick all traces in the gather without any user interaction. So I'll keep the same parameters. We're going to snap to a trough, and now you'll notice that as I go through here at each shot, it's actually picking by itself using an energy ratio algorithm with a 40-second window. In this case, that window precedes the leading edge of the pick window. The other options are modified energy ratio, short-term average, long-term average, and there's an auto-regressive method. So anyhow, we can go through here. I'm clicking through with the keyboard, but for 240 channels, you can see you can click about as fast as you can click, it will pick. So we're 359, so we're about halfway through this data set, which contains 100 and some odd records. If we save that file, and then I look at that file, I'll just show you what ends up being in the file. There's a header here, and it indicates how the data were sorted when you started picking it, how many actual shot locations and receiver locations had been picked, how many first break picks are in the file. One line represents a first break pick here, so there'll be 9,466 of those. From left to right over here we have field file number, channel number, source line number, source location number, source easting, source northing, source elevation. These were source depths and uphole times. This is a fiber size survey, so we don't have either of those. I'm sorry, there's the source depth and uphole. This one here is receiver line, receiver location, receiver easting, northing, elevation. This is the bin line, bin location, which would be equivalent to a CMP location on this 2D line. You have your offset, your azimuth, your pick time, and a flag that indicates that the pick is valid. This will be turned to a 0 when the pick is not valid, and that doesn't come into, we don't use that until later when we're actually doing refraction analysis. And if a pick is considered noisy, or the standard deviation between that pick and the rest of the picks is too large, we can invalidate the pick. So that's the picks, and close that and you're done picking. Hope to see you later.